Okay, now I see a recording. Let's do it. Little do you know, this is the second time I've done this because the recording stopped the first time. So let's start with number 4. We are doing review 5.1, 5.2, 6.1, part 1. So first, number 4, name 2 coterminal angles with 56. Well, if we're going to do coterminal, what that means is that you either take your angle plus 360. So what you're going to do is you're either going to add a revolution or you're going to subtract a revolution, and you can get a coterminal angle. You can actually subtract as many revolutions or add as many as you want. Okay? So here we're going to think about in degrees either adding or subtracting 360, and in radians we're either going to add or subtract a revolution. In that case would be 2 pi. So again, when we think coterminal, we're either going to add a revolution or subtract a revolution. We're going to add a revolution or subtract a revolution either in degrees or in radians. So subtract there would look like that. Okay? So that means for 56 degrees, we are going to add a revolution and get 56 plus 360, that many degrees, and you end up getting 416. It's a coterminal angle with 56. So if you open up 56, you're here. If you waste a revolution and go around, you're still at the same dot. So that means that 56 and 416 get you the same spot on the unit circle. If I subtract a revolution, I'm going to take this minus 360. So 360 minus 56 is going to end up giving you negative 304, right? So 304. So that means down here it's going to be negative 304 degrees. So there's 2 coterminal angles with 56. Number 5. So now you'll notice that number 5 is the radian version of the same question. If I've got this and I want to add a revolution, I look here and I add a revolution. In this case, it would be 2 pi. So if I add 2 pi, that's the same as adding, well, I hit this with a well-chosen 1 of 3 over 3. So I'm going to add 6 pi over 3. So it's going to be 5 pi over 3 is 1 coterminal angle. Or I'm going to take negative pi over 3 and subtract a revolution. And we already said that in this case, 6 pi over 3 is a revolution. So if I subtract 6 pi over 3, I think you'll see quickly that we get negative 7 pi over 3. All right, so that's 5. Let's do number 6. Let's stay in the same place. So let's look at 6. So if I look at 6, using these same ideas of coterminal, if I have 8 pi over 3, again, I can add or subtract as many revolutions as I want. So it turns out in this case, if I add a revolution, I'm going to get 8 pi over 3 plus 2 pi. Well, again, if I hit it with 3 over 3, it's going to be 8 pi over 3 plus 6 pi over 3. One possible answer is 14 pi over 3. But then guess what? If I take 8 pi over 3 and I subtract a singular revolution, well, we already said that one revolution was 6 pi over 3. So if I take this and subtract one wasted revolution, I'm going to get 2 pi over 3, but notice that's still positive, excuse me. So I have to subtract another revolution to force it to be negative. So again, in this case, if I subtract 2 pi, that's the same as subtracting 6 pi over 3. So I get negative 4 pi over 3 is coterminal to my original angle, 8 pi over 3. So this, and that all land on the same spot on the unit circle. So if I go to number 7, let's now talk about the complement and the supplement. If you talk about the complement, that means you sum to 90. If you talk about the supplement, that means you sum to 180. So for the complement, we're going to take your angle minus 90. The supplement, you're going to take, 90 minus your angle. And over here, we're going to take 180 minus your angle to find the supplement. If we're in radians, it's going to be pi over 2 minus your angle, or pi minus your angle for the supplement and the complement. So if I want to find the complement of pi over 3, so that would be number 7. If I have pi over 3 and I want to know the complement, I take pi over 2 minus pi over 3. But how do I subtract those? I've got to hit this with a 3 and a 3, 2 and a 2. 3 pi over 6. What's up? This is 2 pi over 6. I'm getting heckled. It's so horrible. Pi over 6, right? So that's going to be a complement. Now if I need to find a supplement, I take my 180 minus a pi over 3, and notice what I get. I get, if this is 3 pi over 3 is the same as pi, then I'm going to get 2 pi over 3 as a supplement. Now, let's go to number 9. So number 9, if I've got 3 pi over 4, and I want to know the complement, then I take, again, it's 90 minus your angle. But in this case, 90 degrees is written as pi over 2 radians. Now to combine those, I have to use a well-chosen one and get 2 pi over 4 and subtract 3 pi over 4. So I get negative pi over 4 as the complement, but you don't want to give a negative complement, so there is no complement. You have to have 2 positive angles that add together to get 90. When you're talking about a complement, it can't be negative. So now if you have 3 pi over 4 and you want to do the supplement, I take 180, which in this case is written as pi, minus 3 pi over 4, and subtract those. Well, we know that that's just 4 pi over 4 minus 3 pi over 4, which is pi over 4. Okay? All right. Now let's change from radians to degrees and degrees to radians. If you're going from degrees to radians, notice we want to introduce degrees. So we're going to, we want to remove degrees. So you want to remove degree. Then to remove the degree, you're going to multiply by pi divided by 180. That's going to remove your degree if you're going to radians. And if you go from radians to degrees, you are introducing degrees. And so what you want to do is multiply by 180 over pi, right? There's our nice well-chosen one that we've been using over and over again. So let's do an example with those. So the first one is number 11. If it's 225 and you want to turn it to radians, well, then I want to remove degrees. So my well-chosen one is pi over 180. Notice the degrees cancel out nicely. So we're happy. So we get 225 pi over 180, right? So we're going to leave the pi there and get comfortable with that. Even though it doesn't feel like it's closed, it really is, I promise. So 225, when you look at something like that, you can rewrite 180 as 36 times 5. And you can write 225 as 45 times 5. So those 5's cancel out and give you 45 pi over 36. But then I think you can see you can take out a 9, because that's 9 times 5. And that's 9 times 4. So that's where you get 5 pi over 4. Yes? Okay, so there's 11. 12. 12 is change 150 degrees into radians. Again, we want to remove degrees. So the well-chosen one we use is pi over 180. So the degrees cancel out nicely. And we get 150 pi over 180. Guess what? 10 cancels out to give you 15 pi over 18. Guess what? There's a 3 in both, because 15 is 3 times 5 and 18 is 3 times 6. Cancel out some 3's and you get 5 pi over 6. 13, if we want to change 7 pi over 6 into degrees, well, now we want to introduce degrees, so I put it on top of my well-chosen 1. So I'm multiplying by 1, so even though it looks different, it's not. And so nicely we have degrees like we wanted, and the pi's cancel out. So we get 7 times 180 divided by 6, that many degrees, which turns out to be 210. 14, if you have negative 2 pi over 3, again, if you want degrees, you must introduce them because radians are unitless. So I multiply by 180 over pi is my well-chosen 1. Pi's cancel out. You get negative 360 over 3, which today and today only is negative 120. Right? Now, last question on this part of the review. If we have 0 and then pi over 6 and then pi over 4 and then pi over 3 and then up here is pi over 2, I want to know on the unit circle what are the x and y coordinates. Well, we know that x is just the cosine and y is just the sine. So we are going to use our trig hand. And so for 0 radians, it's going to be, since the radius is 1, it's going to be 1, 0, because there's a height of 0. At pi over 6, we're going to put down our ring finger, and cosine is on top, so it's square root of 3 over 2, and sine is on bottom, so that's 1/2. When we do pi over 4, we're going to put down our bird finger, so it's going to be square root of 2 over 2, and square root of 2 over 2. When we do pi over 3, we're going to put down our pointer finger. Cosine on top is 1/2. On bottom is square root of 3 over 2. And here, since the radius is 1, y is 1, but x is 0. That is the first part of the review. See you on the other side for the second.